Today I would like to solve homework number 3.6, and in this homework we have been asked to calculate the power either consumed or generated by each of these elements in this circuit. So if you just take a look, you would realize we have two power sources in this circuit. We have the 12 volt, and then we have the dependent power source down here, where its value is 4V of x, and V of x is defined as the voltage across the 30 ohm resistor. This configuration of these two power sources tells us that these two sources opposing each other, and based on which one dominate the circuit, it can tells us what would be the direction of the current, right? And I don't know it right now before solving the problem, so I'm gonna just assume that the 12 volts gonna dominate. So in that regard, the current would be sent from low to high in the 12 volt, and this is gonna be the assumed direction of the current. Again, we don't know if this is correct or not as of now, but we'll find out. And also, it doesn't matter. You can have it the other way around and still it's gonna work. So the next thing that I would like to do is that I would like to write a KVL, right? A KVL is a balance of voltage. To do so, I also consider a clockwise direction for my KVL, and I'm gonna add the voltages one by one, starting from the 30 ohm resistor. The problem itself tells that the value of the voltage is V of x. But going in a clockwise direction, I will first hit the negative terminal of the V of x. So I'm going to write down minus V of x, right? I'm going to write down minus V of x. And then I reach the 12 volt. Again, a negative terminal is going to be minus 12, right? For the 8 and 7 ohm, because they're in the same direction of the current, both going to be a positive. So it's going to be positive 8I, right? This is consistent with direction of the current. And also positive 7I. And when I reach the dependent power source, it enters with the positive terminal. So that's going to be plus 4 V of x equals to 0. Now, if we take a look at the 30 ohm, we can write down the Ohm law to relate the voltage and current. But one thing that you guys got to pay attention is that the current goes from low to high, right? If you're going in a clockwise direction, the current would be from low to high, and this is not consistent with the voltage sign here. So I'm going to write down V of x equals to minus, actually, 30I. Now, I'm going to replace V of x with 30 minus 30I, and that will simplify the problem to this equation, which essentially 3 times minus 30I, right? Plus 15I. equals to 0, and then from there the value of the current turns out to be minus 0.16 amp. Now, the minus value tell us that the assumption for the correct current direction is actually wrong, and the current is actually goes in the opposite direction. Now, what that tells me is that the 12 volt, if the current is on the opposite direction, the 12-volt battery actually consumes energy. So you can assume that the 12-volt battery is being charged in this circuit. And the independent one, the one that has the 4Vx value, is the one that deliver the energy. Obviously, all the resistors gonna consume the energy. And for the resistor, we can use the power equation as P equals to R resistors I square. So with that notion, the 30 ohm power, P of 30, going to be 30 multiplied by minus 0.16 S square. That's going to be equal to 0.76 watt. Similarly, the power for 8 ohm resistor can be calculated to be 0.204. And the power for the 7 ohm would be 0.17. And if you remember, the positive value of the power uh, means that these elements consume the energy. So if you take a look at the 12-volt battery, what I just mentioned before is that the direction of the current is wrong, and the actual correct direction for the current would be in this direction, right? So with this direction, you would see that the current goes from high potential in the 12 volt to the low. What does that mean? It means that this battery actually being charged and it's consuming the energy. So I'm going to write down P of 12 volt battery equals to V multiplies by I, right? In this case, equals by 12. Now, with this direction of the current, it enters the negative terminal. I'm going to write minus 12 multiplied by minus 0.16, and that's going to be equal to 1.92 watt. And finally, the dependent power source, dependent voltage source, 4Vx. So here, again, the power would be the current enter the positive terminal. So it would be 4 V of x multiplied by I. But remember that we already calculate the value for V of x based on I. It's right here. So this is going to be equals to 4 multiplied by minus 30 I multiplied by I, and that's going to be equal to minus 3.07. Now, based on this result, uh, the dependent power source is the element that actually deliver the energy, and that energy, that minus 3.7 watt of power, would be consumed by the rest of the elements in this circuit, including the 12-volt battery. So this is the end of this example here, and I'm going to upload more examples shortly. Thank you.